Okay, back at it. Boy, am I working hard today. Woo! Woo! Okay, we are doing multiple choice questions today. And, I just thought of something so brilliant. I talked about having a test the Friday before your test on Tuesday, kind of an in class thing. Well, I have totally figured out what the questions are going to be. They're going to be these questions. Yeah, so that will ensure those of you who may not have your whole heart or may not even be doing the big exam, if you still want a good grade on the in-class exam, you will watch these videos because these are the questions that are going to be on the exam. I decided it today. All right, here we go. And I'll mention that class also. This is inference part 2. I'm trying to keep all the videos not too long, not over. I don't want them over 20 minutes or so. So this is inference part 2. And I posted the questions again, and I will start with number 26. Number 26, this question. So if you would like a moment to look at it, pause the video, and then we'll come back at it and do it. Okay, pause off. A commercial for a breakfast cereal is shown during a certain television program. The manufacturer of the cereal wants to estimate the percent of television viewers who watch the program. The manufacturer wants the estimate to have a margin of error of at most 2% at a level of 95% confidence of the following, which is the smallest sample size that will satisfy the manufacturer's requirements. We did one question we haven't done a lot, but we did do one question like this. And so this is more of an algebraic question than, working our way down the list. So let's do it. So if you can see me here, the margin of error is equal to the z star, because this is proportions, times standard error, which is square root of PQ over N. I will write that, square root of PQ over N. So let's fill in the variables we know. We know the margin of error is 2%. So let's start with a 0.02 here equals Z star. 95% confidence. Remember, I'll get the old normal model out here. If it's 95% in, it's 5% on the outside. And we want the 5% broken to 2.5%. So 0.025. 0.025. If you put that in inverse norm, I think you're going to get 1.96, but it doesn't hurt going back and checking again. 0.05. Oh, I don't want 0.05. I want 0.025. Sorry. Don't mean to confuse you. Remember, we have to split that 5% in half. 0.025, and I'm going to get the 1.96. Yes, remember, it's always positive. 1.96, and now we're going to do the square root of PQ over N. Now, listen closely. If no P is given, you want to be as conservative as you can, so you make it a 50-50. So it's 0.5 times 0.5 over N. Now, a little algebraic manipulation. We want to get rid of the radical, so we square it. So it's going to be 0.02 square. We're going to square everything here, equals 1.96 squared. And then this won't be squared because it wasn't a radical. 0.5 times 0.5 over N. And then we want to get N to the other side. So we multiply both sides by N and then divide by 0.02 squared. kind of messy, but I'll talk your way through it. So we're going to multiply 1.96 squared times 0.5 times 0.5 divided by 0.02 squared. And we get 2,401. So I've got to at least have that. So I've got to go up to 2,500, which is the right answer, 2,500 for number 26. All right, next, number 28, and it looks like this. Okay. You could pause for a second. You take your best shot at it. While you're pausing, I will clear the board here. And meteorologists are interested in the relationship between minimum pressure and maximum wind speed of hurricanes. The minimum pressure in millibars and maximum wind speed in knots were collected for a random sample of 100 hurricanes from the year 1995 to the year 2012. A regression analysis of maximum wind speed on minimum pressure produced a 95% confidence interval of, you notice they're both negative, for the slope of the least regression line. Which statement is the correct interpretation of the interval? Now, this is an advanced, this probably be something, the very last topic or something that we would do. But I will say this, in finding it out, the negative and decrease go together for me. Negative and decrease. So if you look at all the answers, there's only one A, two, B is out, C is decrease, D is increase, and E is increase. So that factors out B and D. They're out. So let's look what is in. The probability, when you're talking about a confidence interval, it's expected. It is not probability. So A is out. C, we can be 95% confident. We like that talk. That the wind speeds decrease on average, the two things we're talking about. Now, that looks good, but let's look at E and see what's wrong with it. We can be 95% confident that for any sample of that's our problem, any sample of hurricanes. Yes, C is worded better than E. So we want C. Next, 30. Looks like this. 30. You take a shot at number 30, and then we'll go over it. All right, we're back at it on number 30. It says the management team of a company with 10,000 employees is considering installing charging stations for electric cars in company parking lots. In a random sample of 500 employees, 15 reported owning an electric car. Which of the following is a 99% confidence interval for proportions? Proportions means Z to me, of all employees at the company who own an electric car. Okay, let's start with that 99. That would be a tip for me, that 99% confidence interval for a Z star. we would want half of the 99 in, 1% out, so a 0.5%. So I would go right now to inverse norm and put in 0.005. And I get 2.58, about 2.576. So if you look down for 2.576, aha, we have factored two of them out. B and C, A and B is out. So we're down to C, D, and E. Now, in our random sample, 15 of 500. Ooh, let's see what that is for a percentage. 15 divided by 500 is 3%. So that's your P. Okay, so there.
Teachers, please pardon the interruption. Your lunches are available in the cafeteria from now until 11:55.
Lunches, woo! So I got to keep going, but the lunches, after my video, I get to have lunch. So we're C, D, and E again, and we're looking at 3%. So we're down to C and E. C and E. So now it's just the formula for standard error. There was only one sample given, so it's got to be C, not E. So the answer is C. E would be if it was two sampled. All right. Next. Number 31. It looks like this. Number 31. You take a moment to give it your best shot, then we'll go over it. And it says test hypothesis, null hypothesis, HO mu equals 0 versus HA, alternative hypothesis of mu or mean greater than 0 was conducted using a sample size 7. The test statistic was 1.935. Which of the closest to the p-value for the test? So you're finding the p-value given this. All right, so we haven't done T yet, or means, but we're going to on Friday, so you'll be able to do this pretty soon. So follow me on this. Go to distribution. Go to distribution and go down to TCDF. You know how we did normal CDF? Do TCDF. The lower would be that statistic, 1.935. And the upper, of course, would be 99. Now, the only thing different about a T and a Z, you got the degrees of freedom. So, and it gave us a sample size of 7. Degrees of freedom is 1 less than sample size. So it would be 6. Paste, and I'm hoping I get it. I get 0.0505. So that is D. 31. D is correct. Boom. Yeah, 31 is correct. D. All right, our final problem. I can hear the dinner bell ringing. Is 37, and it looks like this, 37. And it says, in the states of Florida and Colorado, vegetarians investigating obesity in dogs, remember, I prefer cats, but this is about dogs, obtained random samples of medical pet records and recorded the weights of the dogs in the samples. A test was conducted of null hypothesis being equal versus the alternative of them not being equal, where P1 represents the proportion of all overweight dogs in Florida. P2 represents the proportion of all overweight dogs in Colorado. Remember, the null hypothesis would mean they are equal. There is no difference. The resulting statistic for the two sample, meaning some on each side, for the difference of proportions is 1.85 at the significance level of 5%. alpha level, it's called. Which of the following is a correct conclusion? We need to get that p-value first. So let's go to normal CDF. And we want 1.85 on the lower, and on the upper, we want 99. Now, here's the trick. It's a two-sided one. It's not equal to, so we've got to multiply that p-value by 2. And I get 6.4%, 6.4%. So I look at A, and it says there is not sufficient statistical evidence to conclude, meaning if there isn't, it means P is not low, so you can't reject HO. Let me read that one again. There is not sufficient statistical evidence to conclude that the proportion of all overweight dogs in Florida is different from the proportion of all overweight dogs in Colorado because the p-value is greater than 5%. Boom, 6.4. Tricky here is to multiply that by 2 because it's a two-tail. There it is, and it is A. That is inference part 2 complete. I'm excited. Bye.